The lengths of rail that make up a turnout, as well as each of the 200-metre long CWR strings, were joined together permanently using thermit welding. The aluminothermic weld process involves heating the join at two rail ends until they are red hot and pouring a molten metal portion into the gap. The join then cools and takes on the properties of a continuous piece of rail. Special clay moulds are positioned either side of the rail gap. They are manufactured in the shape of the rail profile and sit neatly around the rail itself. The gap between the mould and the rail is sealed with a clay luting paste. This procedure is critical, as any gap not tightly sealed will allow molten steel to run out and destroy the weld. Care is taken to ensure all crevices are tightly packed and sealed, with one man on each side of the rail responsible for this work. Once the mould is sealed, the rail ends are preheated using an oxygen propane blowtorch. The heating time and temperature are critical both to ensure fusion between the portion and rail parent metal, but also to ensure consistency and repeatability of the process. At the prescribed time, a crucible loaded with the thermit portion is ignited above the mould. This reaction reaches temperatures of more than 1000 degrees Celsius before a special heat-activated thimble at the base of the crucible liquefies and the portion flows down into the mould. After a few minutes cooling time, the mould is broken away, exposing the glowing orange metal inside. Again, the timing must be accurate. If the mould is opened prematurely, the liquid metal will flow out. Too long, and the metal will have begun to harden, making the job of shearing and trimming the weld extremely hard. Once the excess metal is cleared away, the weld is sheared flush with the rail and the joint is given an initial hot grind. After the weld is cooled, a final grind is done, in the same manner as for flash butt welding. The joint is then ready for ultrasonic testing. Every rail joint on the project, over 2,500 flash butt welds and almost 1,000 thermit welds, needed to be ultrasonically examined for flaws and defects. This involved a series of examinations with a test rig that sends and receives ultrasonic sound waves, bouncing them along the rail surface. If the receiver does not detect the transmitted wave, it is likely that some type of defect has occurred in the rail. These can take the form of cavities, cracks, or foreign bodies, such as sand from the clay moulds. Aiming the sound beam at different angles ensures that the full profile of the rail is inspected. Any defects that exceeded the limitations set by the contract were removed. This meant cutting the rail 5 metres either side of the fault and replacing the rail with a new section, held in place with 2 new welds.